So let me just give you a sample of what the data look like. Okay, so we've got some student, which will be my co-author, Raj. And then each year, that student has a math test score and an English test score. So in 1992, 4th grade, 1993, 5th grade, 1994, 6th grade. And they'll be in a classroom. And in the early grades, grade 4 and grade 5, usually they have the same teacher for both math and English. So I pulled out some good names for this audience. So they have the same teacher for math and English in grade 4 and grade 5. But then in grade 6, they're going to middle school, where the teachers specialize in one subject, and they have a different teacher for math than English. Okay? Each year they have a different test score, which is this normalized variable, okay, in standard deviations. But importantly, they only have one level of earnings. The student only has one earnings at age 28. Right? This variable, how much did you earn when you're 28 years old, is the same for every single observation in the data set. So what we do is we're going to stack the data and have multiple observations per kid, but then we're going to correct all of the standard errors and the confidence intervals for inference purposes for the fact that the kid is in there multiple times. But you can think about this as kind of the structure of the data set. Okay? So this is just some summary statistics. Class size is average is 28. 76% of the students are eligible for free lunch in school. That's the standard measure of poverty in the US. 72% are black or Hispanic. Annual wages at age 28, including the zeros, because we have a large fraction of students who have no earnings, at least no taxable, no official earnings. We can't, if they're earning in the black market, that's something we're not going to be able to capture, although it turns out it doesn't look like there's that much of an effect on the margin of having zero earnings or not. It's just a little bit over $20,000. 36% are in college at age 20. And that might seem a little high for this group, but we are using college in a very general way. So any higher education institution that's eligible for federal aid is included. Okay? And that includes technical and professional programs. So if you're going to study to be a mechanic, or you're going to study to be to work, you're a hairdresser or anything like that, any certificate program that's eligible for federal aid, you're in this. So it's not just, Columbia University kind of places. Okay? And then this is some parent characteristics. 42% of the parents were ever married, things like that. Okay. So here's getting into the technical part of the talk. We're estimating value added using the following kind of regression equation. So we have the student's test score, achievement for student I in grade G. We're going to control for their prior test scores, and we'll do that in a flexible way. We'll control for a bunch of other characteristics. And then what's left over? You can think about there being two unobservable components that are left over. This term mu here, mu j, we'll say that's the value added for teacher J. That's the impact, the causal impact of that teacher on this student's test score this year. Okay? And then we have this epsilon term, which is all the other stuff that makes that student's test score go up or down that year. That could be measurement error, like, guessing on the test, okay? Or the child didn't feel well that day, or anything else that makes that test score go up and down. The child's parents got divorced, and that caused stress at home. All that other stuff is soaked up into epsilon, okay? And I'll talk a lot about epsilon in a second, but let me just give you the sense of what we're doing first. What we're going to estimate, how we're going to estimate mu j is through taking the residual from this type of regression and averaging those residuals across all of the students taught by that teacher. Okay? Under the assumption that these epsilons, once they're averaged over a large number of kids, will essentially go to 0 in expectation. The average will go to 0 in expectation, and we'll be left with the teacher's contribution. Okay? So what's our main identification assumption here? What's the big assumption we have to make? It's that we don't have students sorting to teachers based on these unobservable components epsilon. That is, we can't have it be the case that a particular teacher always gets students who have positive epsilons or negative epsilons on average. That they're not always getting the kids who are better than they look on paper or are worse than they look on paper. That's a problem for our analysis, and that's what I'll spend a lot of the time today trying to convince you is not happening in the data. Okay? And then, once we have this value-added measure, what can we do with it? Once we have a value-added measure, we can take another outcome, a long-term outcome, and this doesn't have a G subscript on it because, like I said, it's your earnings at age 28. So that's not different between grade 4, grade 5, grade 6. Earnings at age 28, we're going to regress that on the value-added measure, plus the other controls that we had, and then we also have these unobservable components that I'll talk about. So let me point out two things. First, this mu j with a little orthogonal symbol on it. What I mean by that, why we put that in there, is well, I want to point out just something conceptual. What we capture with a value-added measure is the teacher's impact on test scores or anything else that teacher does that is correlated with their impacts on test scores. But that doesn't mean that there aren't other ways in which teachers affect long-term outcomes. So if a teacher affects your earnings at age 28 by teaching you how to sit still, right, and pay attention, that's part of probably an important skill that you need. You're all sitting down, sitting still, paying attention. That's important. Okay? So maybe you got that, part of that from your 4th grade teacher. Okay? If that shows up in your test score in 4th grade, if that improves your 4th grade test scores because during the exam you could sit there and pay attention, we will capture that. Because it's going to be correlated with the test score-based measure of value added, of teacher performance. If it doesn't show up in your test score, but it shows up in your wages, that's okay. It'll be over here. But by definition, this is uncorrelated with this. By definition. Okay? But I just want to point out that there's other ways in which teachers can affect your long-term outcomes that aren't picked up by the test. So that's why when you go to the practical issues around measuring teacher effectiveness, you wouldn't want to only measure that using a test because a test probably doesn't capture everything that teachers do that's useful. And if you have other measures that can capture these other aspects of teacher performance, you'd want to use them. Okay. So that's one thing. And then the other thing is we have this new unobservable term, which is student unobservables that are orthogonal to scores. That is, other reasons I make more money that are uncorrelated with my test scores. Right? Like, I don't know, my dad owns a factory, and I get a job in the factory. And if that has nothing to do with whether I do well on tests or not, but it will affect my earnings, that's important. Okay? So, the beta term here, the relationship between value added and earnings, that's just the covariance. Okay? And that's just going to come out of the regression. And so what's our new identification assumption here in this second stage of the analysis? It's a little bit weaker than in the first stage. What we're assuming is that teacher value added is uncorrelated with the unobservable determinants of earnings, that V term over there. What that means is that sorting to teachers on this unobservable V term, that's okay. As long as it's not correlated with value added, right? So if the factory owner's kids always get a certain teacher, okay, that teacher will always look like their kids earn a lot more money, right? But it wasn't due to them, it was because it was the factory owner's kids. Always like to get her. That's okay, as long as the factory owner's kids aren't being sorted to a teacher that has necessarily high or low value added. Okay, so it's a slightly weaker technical assumption, slightly weaker.